It's that time of the year again in which I work on my project 30 days in a row without having any 0 days. Every day of November I'll be working on GoZen with this year's goal to be able to edit videos with GoZen. GoZen is my free and open source video editor made with Godot. By the end of this month I hope to be able to edit videos with it and render them out. I let my Ko-fi supporters decide what I will be working on first during this month, and the majority has voted for having hardware decoding in GoZen. I started by outlining some of the things I should do and have to do on GitHub, and then set up my system to start working. After my first programming session there were some playback issues. Videos will start playing slower, and checking the memory usage, I noticed that there was a memory leak happening. The memory leak was rather easy to fix by just assigning some null pointers and cleaning up the frame data before loading a new one. Every day during this month I have to invest a minimum of 30 minutes, preferably a minimum of 1 hour, to work on GoZen. I do have quite a busy schedule this month as my second kid is being born this month. I have some freelancing jobs lined up that I need to do. And with my wife in the hospital for over a week, I'll have to do all the housework again. I'm still a stay-at-home dad, so not that big of a challenge, but I still need to get work done whilst also spending a lot of time with my kids. But yeah, I think I'll be able to handle everything. What I cannot promise though is uploading videos daily, just like last year, but I will write daily devlogs of my progress on my website. Link to that in the description. Before we go on, I should mention that video files don't save their frames in RGB, which is needed to display images on a PC screen. Video files use another pixel format called UF. 3 arrays, same as RGB, but 4 pixels would, by example, use 4 numbers in the Y array and would only need 1 from the U and 1 from the V array. So yeah, that will be needed to make up the colors for those 4 pixels. This is only a very simple explanation, but yeah, that's probably all you need to know for now. Hardware decoding was almost implemented, but I couldn't get the last part to work, which is displaying the image properly. The playback was getting messed up, and that was because of the U and V part of the UF pixel format. It took me some time to realize that the pixel conversion was expecting to receive the hardware decoder's pixel format, which isn't UF, but NV12. The only difference is that U and V are inside of one array and they're interleaved. So after that amount of time wasted and that variable changed, playback was finally working. Or is it? I mentioned that the hardware decoder returns NV12, which isn't exactly UF, and the CPU pixel conversion requires a lot more time to process this information for some reason, which is a problem as now it works slower compared to using software decoding. Measuring times made me realize that it's converting the RGB, which is a culprit. I tried separating the U and the V values into separate arrays before giving it to the conversion algorithm, the program SVS, which didn't work. 4K footage with software decoding gives us 500 to 600 FPS, which is quite decent. But enabling the hardware decoding in FFmpeg, yeah, we're only left with 20 to 29 FPS, with dipping in the 18 FPS every now and then. The solution is simple. Pass the data to a shader and let the GPU do all the work, as it is faster than the CPU for these kind of tasks anyway, because it's handling images. But that will be for tomorrow. I did achieve quite a good amount of work today, in my opinion, and this is the changelog for today. One more time, a quick mention for my Ko-fi supporters for supporting me and GoZen. If you want to become one of these wonderful people, you can go to my Ko-fi link in the description, and I'll see you all in the next video. Thanks for watching. Bye bye.